Here we are using monostable multivibrator mode of 555 timer IC. This is also called single shot mode. 555 timer IC remains in stable state until an external triggering is applied. External triggering is given by using a push button to connect the pin number 2 with ground. Pin number 2 is the triggering pin here. Pin number 5 is the control pin. It is pulled down by using a capacitor. Here I have taken it 0.01 microfarad. This pull down capacitor is used here to avoid noise. Pin number 1 is connected to ground. Pin number 4, it is the reset pin. It is connected to plus 9 volt. Pin number 8, it is the VCC pin. It is connected to plus 9 volt. Pin number 6 and pin number 7 are shorted and connected to the RC network. Pin number 6 is the threshold pin. Pin number 7 is the reset pin. Pin number 3 is the output pin. The RC network provides here the time constant. The resistance value and capacitance value are multiplied and then multiplied with a factor 1.1 to get the time here. I have taken here 150 kilo ohm the resistance value and 47 microfarad the capacitance value. That means it is 47 microfarad and this is 150 kilo ohm to get a time which is approximately 8 seconds. This is the time for which 555 IC remains in quasi-stable state. After this time, the 555 IC switches back to stable state automatically. 555 timer IC switches back to stable state after this time. Inside this IC there are two comparators, one RS flip-flop and one transistor. The 555 IC is in stable state. That means the output at pin number 3 is low. The voltage at the non-inverting terminal of lower comparator is 1 by 3 times VCC. Here the VCC is 9 volt, so it is 1 by 3 into 9, which is 3 volt. When we apply the push button, the output of the lower comparator becomes high and the RS flip-flop is set and the output becomes high at pin number 3. The transistor inside the IC becomes off and the capacitor here is disconnected from the ground and starts charging through this resistance. This state is called quasi-stable state and this works for 8 seconds. When capacitor starts charging and the voltage becomes more than 2 by 3 times VCC, that means 6 volt. That means here the voltage at pin number 6 becomes more than 6 volt. That means the inverting terminal of the upper comparator present in 555 IC, the output of upper comparator becomes high, the flip-flop present in the 555 IC is reset, and the output at pin number 3 becomes low. Transistor is on and starts discharging the capacitor through pin number 7. I have used a 12 volt ice cube relay here. This is also works for 9 volt DC. For ignition, I have used a 4 volt 1.5 ampere hour battery. I have used a thin single strand of wire for the ignition purpose. This is a red LED in series with a 1 kilo ohm resistance. This is uh, for visual purpose only. That means when the output becomes high, this LED glows for 8 seconds. This is my relay driver circuit, which is nothing but 1 kilo ohm resistance and an NPN transistor BC547. Initially, make the switch off. The switch here is only on after pushing the push button, because the wire for ignition purpose is used here and connected to the normally connected terminal.